Hi, so I'm Bill Jenkins. I am the Director of AI Product Marketing here at Achronix. Today what we're going to talk about is we're actually going to go over how our FPGAs can unlock conversational AI. So what we're going to focus on as part of conversational AI is automatic speech recognition, ASR. And ASR and conversational AI kind of work together with other blocks. So you have the speech to text portion, which translates then into the natural language processing piece to understand that text that's being said. And then of course some applications want to convert that back to speech based on the response that they're looking for. So in this case, we're focusing on the automatic speech recognition. And so there are different models that get used for AI to do that. We'll show you next what those are. In this case, we're implementing an RNNT model. And part of that model is going to run in the FPGA, and that's what we're actually accelerating. It's the encoder and the decoder part, because those are the real compute-intensive pieces. On the CPU side, it runs the rest of the algorithm. So the two work together in conjunction, with the FPGA being the accelerator. What that translates to, if we looked at an all-CPU implementation, is a reduction from 20 servers to a single server with one FPGA card in it. And that equates to a power and a significant cost savings. To show you an example of that, if we looked at the operating expense and the capital expense of using, say, a cloud environment to do conversational AI for something like a call center or a customer service. A call center will typically get about 50,000 calls a day. Each call lasts about 5 minutes. If you were to deploy that conversational AI algorithm on the cloud, you'd pay between 1 cent and 2.5 cents per minute for some of the major cloud service provider functions, which equates to a cost per day of somewhere in the $1,500 to $6,000. But if you look at that over a year, it's just under $1 million to about $2.3 million, and that's just your operating expense. If you look at what our solution on our Speedster7t card, you'd be looking at both the capital expense and the operating expense of about $100,000 a year. So a significant cost savings. I'm going to show you today is a demo of this system running. So what we've got implemented here is we're at the SC22 booth. We're going to show you that connection that we have to our virtual lab, which is a remote set of servers that are hosting the Speedster7t card, running that encoder-decoder block remotely. So here's the demo. I mean, effectively, we've slowed it down significantly. This will potentially run up to 4,000 concurrent streams of audio at the same time. Right now, for the purpose of the show, it's just a functional demo showing a lot less so that it's readable and eligible. Right now, it's trained on the Libra data set, which is not a very robust data set. It's really someone just reading books and text, and so these sentences are just people reading sentences from the book. What you see in red are errors. So the word error rate it's pretty accurate, being trained on a not very good data set. So eventually this will train on any language, so multiple languages. It's going to be trained on the actual full modern English language data set, which will give us much better performance out of it. But you can just see that it's multiple concurrent streams of audio that we're sending into the system, and it's translating it to text and outputting the text to the screen. So again, I'd like to say thank you. My name's Bill Jenkins, and one of the things that we focus on here is to try to show how our FPGAs in partnership with some industry people, in this case Myrtle, who's working on the RNNT implementation, how that can really benefit people who need to do scalable from several to thousands of concurrent streams in a deployed environment, whether on the cloud or in an on-premise data center. So we look forward to talking to you. If you're interested, please reach out to us. We'd love to chat more.